Hello all. In the previous episode, we have just seen how the raw material for the petroleum refining industry, that is natural gas and crude oil, are explored, drilled and produced. In today's episode, we are going to discuss more about the properties of both these material, that is natural gas and crude oil. What are their physical properties? What are their chemical compositions before we get into the subject of refining. So, this is going to be episode number 4, and the subjects that we are going to discuss about today would be the petroleum chemistry, the composition of crude oil and natural gas, and the physical properties of them. As I said earlier, natural gas and crude oil, they are produced from earth and finally they are taken to refineries and petrochemicals to produce various petroleum products and petrochemical products. So, it is very much essential to know more about these raw materials. First, let us try to understand more about natural gas. Natural gas, as the name suggests, it is occurring naturally from the mother earth and it is a mixture of the lightest hydrocarbons like methane, ethane, propane and butane. It also contains small quantities of water, hydrogen sulfide, carbon dioxide, nitrogen and sometimes very small amounts of helium. And there are two different forms of natural gas as they occur. The number one is known as associated gas. So, as the name suggests, it is associated with crude oil. In a crude oil well, the gas comes along with the crude oil. It is also called as a wet gas because most of the time it is a mixture of not only methane and ethane, but it also includes propane, butane and pentane. The second type of gas is known as a dry gas. Primarily this comes from gas field, pure gas field, and predominantly it contains methane and ethane which are gaseous in nature. So, that is the reason it is called as a dry gas. Density of natural gas is 0.68 kilogram per standard meter cube. So, that is it is lighter than air. Consequently, it rises quickly in the air. So, this wonderful property it makes as one of the safest fuels in the hydrocarbon industry. So, that means whenever there is a leak in natural gas, so it immediately escapes into the air, unlike LPG. LPG is heavier than air and most of the time it will settle down and it will be a potential safety hazard. But contrary to LPG, natural gas is very much lighter and escapes and hence it is one of the safest fuel. According to the natural forms, it is also comes under 3 categories. One, as I said earlier, it is an associated gas, it can be a wet gas or natural gas. So, primarily directly coming from the well that are being dug. The second form of natural gas is gas hydrate. This is primarily a solid form of water in which the methane is entrapped. So, it is a combination of water and methane, but mostly seen as a solid form. The third category is the methane available while you are mining for coal. So, it is coal bed methane. So, the natural gas is trapped or embedded within the coal bed, which is known as coal bed methane or in short known as CBM. And there are different terms today being used for natural gas according to the way it is being taken to the market. So, number one is known as compressed natural gas or CNG. So, it is made by compressing the natural gas to less than 1% of its volume. So, the natural gas is very much compressible. It is always compressed and then transported so that the transportation cost is minimized. So, this compressed gas is known as CNG. Then liquefied natural gas, it is about reducing the volume by 1/600th of the volume so that the gaseous fuel is converted into liquid. Now, it is easy to be transported. The third one is known as piped natural gas or PNG. So, this is primarily sent to the end customer through pipeline. So, whether it is a domestic customer or an industrial customer, it is sent through pipeline. So, it is also sometimes known as city gas. So, city gas distribution or CGD is a frequently used term in the industry. Now let's move on to understand more about crude oil, the primary raw material for the petroleum refining and petrochemical industry. So again, crude oil is a mixture of several hydrocarbons. So almost more than 500 organic chemicals are part of crude oil. It also contains water, hydrogen sulfide and small traces of metal. So this is since it is a mixture of hydrocarbon, it is taken to a refinery so that these hydrocarbon is split into different streams to produce different kind of petroleum fuels and petroleum products. So now let's try to understand the major hydrocarbon families that are present in crude oil. The number one is paraffins. Paraffins, the general formula for paraffins is CnH2n plus 2. The first three compounds, methane, ethane, propane, they are gaseous in nature, and compounds up to C16 are liquids, and beyond that they assume semi-solid consistency. So when I mean C16, it is a compound where 16 carbon atoms are there. So the rest of them would be hydrogen. So that is why these compounds are known as hydrocarbons. C30 and beyond assume the shape of solid blocks, sometimes even crystalline forms. The second hydrocarbon family is olefins. Olefin, also called as alkane, are compounds made up of hydrogen and carbon that contain one or more pairs of carbon atoms linked by a double bond. So this is how the olefins are differentiated between paraffins. They are rare in nature, but generally they are formed in large quantities through industrial processing. So especially cracking process which is happening in the refinery. The third category is known as naphthenes. Naphthenes are a class of cyclic aliphatic hydrocarbons obtained from petroleum, and the naphthenes have the general formula CnH2n. These compounds are characterized by having one or more ring of saturated carbon atoms. Then the fourth family is known as aromatics. Aromatics are generally characterized by their smell. Aromatics are organic compounds that consist exclusively of the elements carbon and hydrogen, and predominantly they have a ring structure. The major and popular aromatic compounds are benzene, toluene and xylene. Now, having understood about the different major hydrocarbon families, let's try to see how the crude oil is classified based on the hydrocarbon composition. The first one is known as a paraffinic base crude oil. So a crude oil containing more than 5% of paraffins is known as paraffinic base crude oil. The next category is naphthenic base crude oil. A residue or a crude oil containing less than 2% of paraffins is known as naphthenic base crude oil. And any oil which has got the paraffin content in between 2 to 5%, it is known as intermediate base. So these are all some of the commonly used terms in the oil market. Now there are different terms which are used while trading crude oil. If you see the crude oil exchange or where the crude oil is being traded, some of the terms are frequently used. They are Brent crude, TWI crude, Dubai crude. So what are these crudes? These crudes are supposed to be known as benchmark crude oil. Crude oil composition varies from place to place and the place of occurrence. So whenever a new crude is brought to market, so it is always tried to be compared or benchmark against one of these standard crudes. The Brent crude is a mix of crude oil from different fields in the North Sea, that is somewhere closer to United Kingdom, and it is the benchmark used primarily in Europe. So Brent crude is popularly traded in the European market. Then the second crude that is very much popular in the US is the Texas Western Intermediate. So this is a crude available in the Texas region, and this is popularly traded in the US region. The third one is Dubai crude. Dubai crude is also known as Fateh, and it is a heavy sour crude oil extracted from Dubai. So these three major crude oils represent the crude oils obtained from different parts of the globe. So now you may be wondering what is sour crude oil. Probably in the next few slides I will be explaining about what is a sour crude and a sweet crude. Once a crude oil is obtained and when it is sold in the market, it is essential for the refiner to understand the characteristics of crude oil. So even before the crude oil is purchased, they would like to know whether this crude oil is suitable for their refinery, because every refinery configuration is different and every refinery cannot process all kinds of crude oil. So it is essential to understand the composition of the crude oil, and the composition or the thorough detailed test of crude oil is known as crude oil assay. Whenever crude oil is marketed, the crude oil assay report is also given to the end customer, and of course it is also the responsibility of the buyer to repeat these tests and ensure that the properties are matching with the report given by the seller. So primarily crude oil assay is the chemical evaluation of a crude oil feedstock by petroleum testing laboratories. Each crude oil type has a unique molecular and chemical characteristics based on their place of occurrence or the place of origin. No two crude oils types are identical, and they are crucial differences in crude oil quality. The results of crude oil assay testing provides extensive detailed hydrocarbon analysis data for refiners, oil traders and producers. The assay data help refineries to determine if a crude oil is compatible for a particular petroleum refinery, or if the crude oil could give the expected yield of petroleum products, quality of the products, production and environmental related issues are taken in upfront. So this is the reason why the crude oil assay is very much important for refining industry. And the crude oil assay consists of a compilation of data on properties and composition of crude oil. The assay provides critical information on the suitability of crude oil for a particular refinery and estimating the desired product yields and quality. And it is not a single test, it is a comprehensive test of crude oil. What are the tests that are covered under the crude oil assay? So starting with the API gravity, the sulfur content, pour point, viscosity at different temperatures, and the metal content, for example nickel and vanadium, the total nitrogen content, total acid number, distillation data characteristics, distillation data, and finally the characteristic factor. So these set of tests and reports form the crude oil assay. Now let us try to understand the significance of each of the tests and how they are performed at a very high level. The first and foremost test for crude oil is the API gravity. It is the indirect representation of density of crude oil. The different kind of crude oil, the densities vary in the second decimal or the third decimal. It is very difficult to compare them. So that is why a new measure known as API gravity. API stands for American Petroleum Institute. So this particular unit magnifies the density, and it is very easy to compare different kind of crude oil based on the API gravity. The formula is very simple. Degree API is equal to 141.5 divided by the specific gravity minus 131.5. So since the specific gravity is in the denominator, higher the API gravity, lighter the crude oil, and lower the API gravity, heavier the crude. So it is very much easy to understand whether based on the API gravity, it is easy to say whether a crude oil is light or heavy. This is also a common term which is generally used in the industry, whether the crude oil is light crude oil or heavy crude oil. Of course, this is a subjective thing, but generally the light crude oils are liquid petroleum that has low density and flows freely at room temperature, whereas heavy crude oil, they are denser in nature and they have resistance for flowing. and this lighter crude oil has got a low viscosity. Lighter crude oil has got higher price because it is easy to process crude oil, the lighter crude oil, and it is easy to produce petroleum products, whereas heavier crude oils are difficult to be processed and a lot of cost is involved in removing the impurities from the products. So that's why the heavy crude oil is generally cheaper compared to the light crude oil. Now let's try to understand we know that crude oil is a mixture of several hydrocarbons, but beyond the hydrocarbons there are several other impurities present in the crude oil. What are the impurities? Sulfur, oxygen and nitrogen. These are the major impurities present because of their inherent properties like odor, color and corrosiveness. Since they do not give a pleasant odor and they do not give a pleasant color, and they are also corrosion causing substances, and because of that reason these are known as impurities. Generally these three elements combined together do not exceed 5% on an average. Now let us look into the sulfur content in the crude oil, because this is very much vital to understand about the sulfur content in crude oil. Sulfur is found most in the crude oil in variable amounts. Generally the sulfur compounds are present in more quantities in higher molecular weight stock, that is heavier the crude oil, the sulfur content will be more, and because of that reason the cost of heavy crude oil or the crude oil which has got more sulfur content, that will be cheaper compared to a light crude oil. Usually the sulfur content does not exceed 5%. However, rare exceptions are there. Sulfur in crude oil occurs in different forms like free sulfur, hydrogen sulfide, mercaptans and thiophenes, etc. And based on the sulfur content, the crude oil is also categorized into sour crude and sweet crude. Any crude oil which has got more than 0.5% sulfur is known as sour crude. Again, the sour crude is heavy and it is also cheaper, while any crude oil which has got less than 0.5% sulfur is known as sweet crude. Sweet crudes are generally lighter and they are easy to distill, and hence they are relatively costly. Why we call it a sweet crude? Because generally the crude oil which does not have any sulfur, they have a pleasant smell, and because of that reason they are known as sweet crude. The next important property of crude oil is the pour point. Pour point of a crude oil is the temperature below which the liquid loses its flow characteristics. That means below the particular temperature the crude oil cannot move from its container on its own. It is defined as the minimum temperature in which the oil has the ability to pour down from a beaker. In crude oil, a higher pour point is generally associated with a high paraffin content. So, if a crude oil has got a more paraffin content, then the crude oil will resist to flow. So, then it is known as a crude oil which has got more pour point. And to test the pour point of a crude oil, there are standard test methods used, and the standard test method used in the industry is ASTM D97. The next property of crude oil is viscosity. Viscosity, commonly depicted by the symbol mu, is a physical property of a fluid that describes its tendency or resistance to flow. So, viscosity is a critical factor because the viscosity of crude oil is going to determine the pumpability factor. So, if it is highly viscous, then you have to put more energy to pump that fluid from one place to the other. Power requirements to transport, that is for pumping or transporting in a pipeline, the fluid depends strongly on the fluid's viscosity. The viscosity of a crude oil can be measured using a standard method, that is by ASTM D2983, and it is measured using an instrument known as viscometer. Then comes to the metal content of crude oil. The predominantly present metals in crude oil are the nickel and vanadium. Metals present in crude oil such as nickel and vanadium are poisonous to the catalyst, while the crude oil is being processed in the refinery, specifically the fluid catalytic cracking unit known as FCC unit or hydrogenation plants, where the catalyst may get spoiled and the further processing of the oil will be hampered. These metals also may cause fouling of heat exchangers. Nickel and vanadium in crude oil can be tested using inductively coupled plasma optical emission spectroscopy. Using this sophisticated setup and using the ASTM test method D5708B, the metal content of crude oil can be detected. Then the next one is known as TAN, or total acid number. Total acid number of a crude oil is a measure of the corrosiveness of the crude oil due to the presence of acids, particularly the naphthenic acids. If a crude oil has got a higher TAN number, then we have to take care of the corrosional aspects in the refinery, because throughout the refinery we use the ferrous, the metal, whether it is a pipeline or a pump, heat exchanger or a distillation column. Throughout the entire plant we use ferro alloys, and this crude oil which has got a higher TAN number should not spoil these equipments. Generally, an acid number of anything over 1 is considered high. Often high acid crudes are mixed with low acid grades to reduce the average TAN number, so that they can be easily be processed. So generally, before taking the crude into the refinery in offsite facility, there is an option to do blending of the crude oil. Suppose you have bought a batch of high TAN number, then you can mix it with the low TAN number crude oil and then take it to the refinery, so that the refinery operations can happen as usual. Then yet another important characteristics is the UOP characterization factor. The UOP factor, or in general characterization factor, is a systematic way of classifying a crude oil to its paraffin, naphthenic or intermediate or aromatic in nature. So by seeing the number, the UOP characterization factor, one can classify whether the crude is paraffinic, aromatic, naphthenic or mixed base. 12.5 or higher indicate a crude oil of predominantly paraffinic constituents, while 10 or low indicates a crude of more aromatic in nature. The formula for UOP characterization factor is very simple. So it is generally denoted by the letter K. K is equal to the cubic root of R divided by 0.827 into rho, where R is the average boiling point in degree Kelvin and rho is the specific gravity at 15.5 degrees centigrade. So R, it can also be indicated by cubic root of T divided by rho, where T is the temperature in Rankine scale. Then the next factor that is very much important in the crude oil assay is the correlation index. Correlation index is equal to 48,640 divided by TB plus 473.7 rho minus 456.8. So this is where the TB represents the boiling point, molar boiling point in degree Kelvin. Rho is the specific gravity at 15 degrees centigrade, and the correlation index for paraffin is taken as 0, and for aromatics it is taken as 100. So the correlation index values are not quantitative, but it gives a kind of indication. Lower the Ca value, the greater the concentration of paraffin hydrocarbons in the fraction. Higher the Ca value, the greater the concentration of naphthenes and aromatics. Then the last and important test is the TBP analysis, the distillation characteristics of the crude oil as tested in the TBP apparatus. This is the distillation characteristics of crude oil, which are assessed by performing a preliminary distillation called true boiling point analysis, known as TBP. This test enlightens the refiners with all possible information regarding the percentage quantum of fractions, base of crude, and the possible difficulties beset during the treatment operation, etc. So, as soon as the crude oil batch is procured in the refinery, they perform a TBP analysis. So, that will give them a lot of insight how to run the plant with that particular batch of crude oil. So, here a batch of crude oil is taken in the flask of a TBP apparatus. A TBP setup has got a flask, a condenser, a thermocouple and heating element. So, as indicated in the picture, the apparatus got a provision to cool the hot vapors, condense the vapors into liquid. As the oil is heated in the flask, the hot vapors are condensed and collected into the measuring jar. The temperatures are noted down as and when specific volume of liquid is collected in the measuring jar. The details observed, that is the temperature versus volume, are plotted in the TBP curve. There are few other tests which are equivalent to TBP curve. They are known as ASTM curve and EFE curve. Instead of TBP curve, ASTM curve, American Society for Testing Materials, can also be used to represent the qualities of the crude fractions. The second one is EFE curve, which stands for equilibrium flash vaporization, which can be run at pressure above atmosphere or under vacuum. And even though these boiling curves are constructed under different distillation conditions, it is easily possible to translate one curve to another curve by conversion correlations. All these curves of crude oil give an insight to the refiner on what quantum of products they will be able to produce, and whether the particular crude is suitable to get processed in the multiple units of the refinery. That kind of insight is obtained from these TBP curves. So, starting with the API gravity, sulfur content, and then the characterization factors, the metal content, and finally the TBP analysis, they are all part of the crude oil assay, and the crude oil assay is very much essential before we get into the process of refining the crude oil. So, in summary, today we have seen that crude oil and natural gas are the raw materials for the refining and petrochemical industries, and it is essential to know the composition and characteristics of crude oil and natural gas. The composition of crude oil and natural gas vary from place to place, and that is the reason for every batch of crude oil we try to do a comprehensive test known as crude oil assay, and this crude oil assay comprises of various physical properties and the chemical composition test and their results. So, with that we conclude today's session. Let us look into the various aspects of petroleum refining in the coming episodes. Thank you so much.